Welcome to this video in the Palo Alto series. In this video, we will learn how to deploy Palo Alto Firewall using AWS Marketplace and AWS EC2 service. We will also break down the setup from the very beginning up until we get the Palo Alto Firewall up and running. So stick to the end of this video to learn how you can deploy Palo Alto Firewall using AWS Cloud. Also, before we get started, make sure you go down and click the like button on this video if you enjoy this content, and also subscribe so you can get the latest video as soon as they get released. Before we get started, let's take a quick look at our topology. In this topology, we are using the Palo Alto recommended design for deploying Fortigate on AWS, and we have basic lines here that we need to configure on our EC2 to get this Palo Alto virtual machine up and running. First off, we need 3 different interfaces to deploy Palo Alto virtual machine inside AWS. Unlike a Fortigate virtual machine, we only needed 2 interfaces. And here we just need to make a small tweak to our setup where we're going to create a first interface for management so we can manage our firewall through the internet or internally. And then we're going to make 2 different interfaces, which are Ethernet 1 and Ethernet 2. And those are to represent the public subnet and the private subnet. And to be able to protect our virtual machines or other resources that we deploy inside AWS, we make an arm for the firewall or an interface for the firewall inside the private subnet so that our virtual machine can talk to the firewall to get to other networks and to talk to the internet, for example. And finally, the firewall will also have an arm or an interface in the public subnet so that it can communicate to the internet and can allow the clients in our private subnet to talk to the internet through the firewall. Now let's switch to VPC, and we're gonna create our first VPC. And for those who are not familiar with VPC, VPC is just a way for us to create networks in the cloud. So basically everything has to be built inside a VPC, like our virtual machines, our firewall, any other services that we use like RDS, all of them have interfaces inside our VPC. So therefore we first need to create our VPC. We're just gonna call it Palo Alto, and we're gonna give it like a big subnet mask like 10.10/16. This will allow us all the subnets that we need inside and more for future growth. And we just save it like that, and then we can work on our subnets. And subnets allow you to segregate traffic between different resources and control them differently using route tables. So therefore we need to create 3 different subnets for our management subnet, our public subnet, and finally our private subnet. So let's start by our public subnet, and we're going to choose our VPC from the list. And then we're going to be asked to choose our availability zone. An availability zone represents a data center for AWS inside a region. So therefore, for my specific region, which is North Virginia, there are 6 different availability zones, which represent 6 different data centers that AWS own in North Virginia, and they are completely isolated and completely separated. So assuming some disaster happen on North Virginia and one of the availability zones goes down, the other 5 are completely isolated and not affected. And therefore, if you build your applications in different availability zones, they are highly available and more prone to data center outages. So therefore, in our case, we can either go with no preference or we can specifically choose one availability zone from the list. Now you have to be careful when choosing the availability zone. I would recommend you choose A, B, or C because I previously had failures deploying it on 1E, and it said that Palo Alto is not supported in that availability zone, which doesn't make any sense, but this is the case we have to deal with. So I will be choosing US East 1B, and then we will choose a subnet mask for our public subnet. Let's just choose 10.10.250/24. This will give us more than enough IPs for current and future deployment as well. Now we have our public subnet created. We can go ahead and create our second subnet, which is going to be our private subnet. We can choose availability zone again, or automatically once you have one created, it usually tries to match it with the same availability zone. And finally, for the mask, let's give it a little bit bigger network like 10.10.10.0/23. This will give us more than 500 IPs that we can deploy as many virtual machines and AWS services as we want. And finally, we just create our management subnet, choose our VPC again, and for the subnet mask, we'll choose 10.10.12.0/25. And now we have our subnets ready. We need to move on to route tables. And with route tables, we need two different route tables to control our traffic between the firewall and our private network. The way this works is we start with our default route table, which is just has our local network right now or our VPC CIDR. I like to rename it first so it would show what it actually is. So let's give this one a name, private route table. And then we can proceed and create our second route table, and for this one this will be our public route table. And as of now both route tables are completely the same. There's no difference, you only have the local route table. So the only difference we're going to make between the public route table and the private route table is that the public route table will have a default route to the internet. This is represented by the IGW. So we can go ahead, edit our route, and add our default route 0.0.0.0/0. And for this one, we will point it at the internet gateway. In AWS term, internet gateway is just a way for you to access the internet. So a requirement for being able to connect to the internet from AWS, first you need Elastic IP, which is a public IP, and second, you need an internet gateway so you can reach the internet. So once we add our default route, now our public route table is ready. We just need to associate it with our subnets that we want to be exposed to the internet. As of now, there is no subnet association under this route table. So we can go ahead, edit our subnet, and we can assign this public route table to all the subnets that need internet connection. We assign it to the management subnet so we can have access to our firewall to manage it through the internet once we deploy our machine. And we need the public subnet so that the firewall will have a presence in the public subnet and can control the actual data traffic between our virtual machines and the internet through that isolated interface. So for the Fortigate, we were doing the public and management under one interface, whereas in the Palo Alto, we will do it in two different separate interfaces. Now our public route table is ready with all the needed routes and also the subnet association. On the other hand, the private route table is currently not associated with any subnet, so we need to point it to the private subnet right now. And we also need to add a route to point our default route in the private subnet to the firewall. But because our firewall is not currently built, we cannot add this step, but we will add it by the end of this video. Now we have all our VPC requirements ready, we can go ahead and move to EC2. And EC2 is the best place we can use to deploy virtual machines in AWS Cloud. And once we go ahead and launch an instance, we can just search for Palo Alto. We will find different offering in the AWS marketplace for Palo Alto. And we may notice Palo Alto recently changed their logo. They have a really nice new logo now. And this is really a nice step in the right direction because they haven't been doing much in the design lately. Now our options start with Panorama. And Panorama is just a central management suite. So it's not the actual firewall, it's just a management suite if you have multiple Palo Altos and you want to control them easily. This is something similar to FortiManager in Fortinet terms. So we are not looking for Panorama right now. We have our bring your own license model next, which is only used if you already have a license. We do not have a license right now, so we want to use the on-demand instance. And with on-demand, we have two different bundles with two different pricing. And if we try to expand our bundle to see what is this all about, it's going to send us the AWS Marketplace page dedicated for this instance. If we try to open this, this will show us the actual difference between the bundle 1 and bundle 2, as bundle 2 allows us to control traffic as usual, but also will allow us to use all the advanced feature or UTM feature that we are familiar with, like IPS, intrusion prevention, URL filtering like internet proxy, so you can filter traffic based on the category and things like that. Also, wildfire and other sandboxing technologies that can help you get the most out of your Palo Alto firewall. On the other hand, the bundle one, which is a little bit cheaper, contains only the IPS license, and we are not going to be able to use URL filtering or any other feature beside IPS. So you can weigh your options based on which model do you need or which features you need to enable. And also it's good to know that just like the Fortigate, there is a free trial for 2 weeks for this instance. So you can try it risk free and you're only obligated to pay for the EC2 cost, which is the actual virtual machine where the Palo Alto software is deployed. So you don't have to pay for the software, you just have to pay for the EC2 cost. You can go down all the way and get an idea of how much would that come to. So right now we are looking into the vendor recommended instance size for this particular virtual machine, which is M5X large. It's definitely more on the expensive side and it contains 4 CPUs and 16 gigs of memory. Of course, this is not justified as a beginner instance side, but this is the one that is recommended for high production environment and mission critical applications. But the total cost for the software and the virtual machine together will be around $1.50 an hour. So keep that in mind also when considering long-term commitment can save you a lot of money if you decide to use this device for your production environment. Once we are happy with the pricing and the information, we can go ahead and click continue to subscribe. And don't worry, that doesn't mean any commitment on your side. That just means you are allowed to deploy this specific machine on EC2 Marketplace after you subscribe to it. So you only get to pay once you deploy the actual machine and actually start using it. So now we can go ahead and start to deploy our virtual machine. We will choose the bundle 2 that has all the features inside. And once we get to the instance size, we will see a lot of instance types that are not supported by this product and they are all inactive. So we will have to go down all the way until we find the first available option, which is M5N. But be careful, do not choose this. It's very misleading because this one is actually not supported. You have to go down more and choose the M5X large, not the M5N. So make sure it doesn't have the N letter and then you can go ahead and deploy it. It's gonna give us first a warning that you are only allowed one free trial instance. So make sure you do not deploy two firewalls at the same time. Otherwise, you will have to pay for the software cost and the free trial will not save you in this situation. And now for the subnet selection, we did say that we need 3 interfaces on all of these 3 subnets. However, as a requirement, we need to make sure that our interfaces are created in the specific order that is specified in the document. Therefore, we will start by the management interface alone in our wizard to create the instance. And after our virtual machine has fully loaded and everything, we can actually start adding additional interfaces to it. And this is the only way to get it to work properly. So as a beginning wizard, we will just choose the management interface and also assign it a public IP address so that we can control our instance remotely. And we don't need to change anything else. You can leave the network interfaces part for now. We will do that later. And we can just go ahead and review and launch our instance. Now, once we get the choice for the key pair, with previous setups, we did not really need a key pair for the Fortigate firewall because the Fortigate assigns the instance ID as the initial password. But for Palo Alto, this is not the case. In this case, we must create a key pair, and this key pair is going to be the only way we get initial access to our firewall to change our password. So keep that in mind. You have to create a key pair. And now our virtual machine is actually showing in running status, but don't fall easily for this. That doesn't really mean the machine is ready for use. If you go ahead in the instance setting and use the instance screenshot feature, this will allow you to make sure that the machine is actually finished booting and is not in this case. So we have to wait until we actually see something like VM login, and that means we are actually right now ready to use the machine. Now, to use the machine using SSH, I want to show you how you can use a tool like SolarBuddy, and I'm a very big fan of this tool because it helps you manage a lot of profiles for different SSH connection, and you can save them already and log into them back and forth. And also it has a very good feature that it allows different tabs inside the same console, whereas the normal Buddy client does not have tab support. So SolarBuddy is just an addition above Buddy, and it's free to use. I highly recommend it. And from the SolarBuddy, you can just click the three dots to open the menu, and we will use the generate certificate option to convert this key pair we just downloaded into a private key file that we can use to the login to the firewall. So once we choose the file that we downloaded in the key pair section, all we need to do from here is just to save it as a private key and save it in the same name but with PPK format. PPK refers to private key, and we no longer need the body generator. We just need to create a new profile now, and we can just call it Palo Alto Firewall. We can give it any name we want. For the IP address, we will use the IP address of our management interface, which is 382.49.64. Now, if we go down, we need to specify our username. That will be admin. We said we don't have the password, but we can point to our PPK file we just generated, and we have to give it a specific name for our setup. Let's just give it Palo key, and then we can save it. And this will allow us to log into the firewall. Initially, it will say welcome admin and wouldn't ask for a password because we are already authenticated using the private key file. In Palo Alto Firewall, you have to start with the word configure to get into the configuration mode. Then we just need to enter one command, which is set management config users admin password. It's just a whole static sentence that we need to enter. And this will ask us, what do you want to change the password to? And we can just choose any password we want. And it has to be strong. You can't just use admin. It will not work. Now, once it says okay, we also have to save this configuration. Unlike the FortiGate, the Palo Alto, you have to do a commit or write to save this configuration to the firewall. Once this has been committed, we are ready to use our firewall using a normal HTTPS session so we can have access to our management console. We will take the IP address of the management subnet and add HTTPS and browse to it. From here, we can log in using our admin password we just changed using the CLI. We will get some information about the PAN OS, which is the operating system running on the Palo Alto firewall. And although there are some nice features coming with this version, unfortunately, this UI has been really outdated, hasn't been changed for as far as I know on Palo Alto. So this is a big problem for us, but at least the product is really strong with everything else beside the UI. So don't let the old design discourage you. I'm pretty sure with the new logo, you have to come up with a new layout and change the logo at least in the management. We also see the management IP address for our management interface, and it does match AWS IP address. So everything right now is ready as far as the management interface. Now we are ready to go and create our additional interfaces. So what I like to do first is to name my management interface, which is the only interface we have right now. You can go ahead and create additional interfaces to attach to our virtual machine. We needed one for the public NIC, and this has to be the second interface by order. We assign it to our public subnet. And for the security group, this is the firewall policy on this specific interface. We just give it the same security group that was created with the machine and go ahead and create it. For this one, we can also give it a name, public NIC. And there are two things we need to do for every interface on the firewall. First, we have to attach it to the actual firewall. This can be done with the machine running in the same time, which is amazing because we don't have to waste time on rebooting or turning off the machine. Second thing, we need to disable the source destination check. And if you are wondering what that is, this is just a security check that makes sure that in order for AWS to honor specific traffic hitting an interface, the IP address of the interface itself must be either the source IP or the destination IP in the packet. And this is not going to be the case in the firewall world. For example, if you have a virtual machine deployed on EC2 and you're trying to access the internet from this machine, in this case, the source IP will be the IP address of the machine, and the destination IP will be whatever IP address that on the internet. So if the traffic packet hits the firewall with a source IP and the destination IP that do not match this interface, it will be denied automatically and the firewall will just be useless. So you always have to disable source destination checks for any firewall on AWS. This is very important to get the full functionality of the firewall. And once we do this, we can go ahead and create our third interface, which is going to be our private interface. Just going to give it the name private NIC and also choose our subnet and our security group that was already created with the EC2 launch wizard. Finally, we give it a nice label, and this also helps us really modify our route tables and point it to the correct interface using the alias that we gave it. Now finally, we do the same thing for our private NIC. We disable the source destination check to make sure our traffic will go through the firewall. And finally, we attach this third interface to our working Palo Alto firewall. Now all our network interfaces setup is now ready. We can now go back to our Palo Alto firewall and get to the network tab so we can start modifying our interfaces. And you may notice the Ethernet 1.0 is not in the list, but it does exist, and it's actually the management interface where we're managing the firewall right now. The Ethernet 1.0 is hidden from this menu, but it was on the main screen on the dashboard. Now, in order for us to get the public interface and the private interface to show up correctly, we have to modify them with specific parameters to get them to work like we want to. So starting from Ethernet 1.1, which is our public interface, we need to change our interface type to layer 3. That means we're gonna allow routing and allow IP address to be assigned to this interface. We can also give it a comment in here as well to make sure we don't mix this up with the management interface, because this shows up number 1 in the list but is not the first interface. And then we go into the IPv4 and change the mode from static to DHCP client so it can get the IP addresses from AWS side. Finally, under config, we need to assign it to a virtual router. Virtual router is just like a route table that contains our network, and we need to assign the interfaces to that route table by assigning it to the virtual router default. And also Palo Alto support security zones, and it's just a logical grouping format that allows you to create different zones for different areas in your network. And this is just for management purposes, but we can create one for our public subnet, and we're just gonna call it public zone. Now our public interface is ready. We can do the same process using our private interface. We're gonna go ahead and change the interface type to layer 3. And then we need to enable DHCP client on this interface. But we also need to make sure that we disable the create default route for the private interface. Finally, we give it the default virtual router and also create a separate zone for this and just call it private zone. And finally, we save our second interface. Now to get these changes to take effect, we need to do a commit again. And from the GUI, we can actually see a preview of the changes similar to the Fortigate. So in here, we can see a side-by-side configuration file before and after the proposed changes. And it would show us a breakdown of how the CLI structure is on the Palo Alto firewall. So we can see the interfaces getting updated and the different syntax being used in here. It's definitely more on the complicated side compared to Fortigate firewall, but still not the worst compared to other firewalls as well. So this is how the CLI is structured in the Palo Alto world. Once we are comfortable with the file, we can go ahead and do commit. And in just a few seconds, our changes will be completely pushed to the device. To be able to verify if actually changes took effect, we can click on the dynamic DHCP client, and this would show us which IP we were able to generate from the outside DHCP server. So this would show us the IP address of the public interface, and it does match AWS, but it doesn't show easily outside. We have to click client to be able to see it. Same for our private interface, we were able to get the IP address from AWS side as well. So all our network interfaces are ready for use. Now the last step for us to get the firewall to protect our private network is to go back to the private route table and to add a default route, this time to the private interface of the Palo Alto firewall. And this way, any device on our private network wanna talk outside of the subnet will need to go to the firewall to be able to talk to it. And that's how you configure and deploy Palo Alto Firewall on AWS EC2. Thank you for watching.